Hello, everyone. In this video, I will introduce our latest work, Unleashing Multimodal Large Language Models for Training-Free HOI Detection in the Wild. Humans interact with objects around them continuously in daily life. Thus, recognizing and detecting these interactions is crucial for agents to grasp the environmental context and engage efficiently with people. Given an image, our goal is to detect a set of human-object interactions. This involves identifying the bounding boxes for both the human and the object instances, as well as classifying the object and interaction categories. Most existing HOI detectors follow a supervised learning paradigm. They learn interaction classifiers from large-scale datasets with manually annotated labels. This paradigm has two major limitations. First, the supervision is expensive. Exhaustively annotating HOIs is costly due to the open vocabulary and verb-noun compositionality. Second, models often struggle to generalize to unseen interactions, new image styles, or degraded visual conditions. To address these challenges, we propose AgentHOI Base, a training-free HOI detection baseline that leverages the complementary capabilities of vision foundation models. First, Multimodal Perception Module utilizes an MLM to recognize possible human-object interactions in the image. Then, Spatial Localization Module uses a grounding model to localize the corresponding instances. However, a naive training-free pipeline is still not enough. The first challenge is incomplete interaction recognition. One-shot MLM reasoning often focus on only the most salient action and overlook less obvious or concurrent interactions. As illustrated by the plot on the left, this problem is particularly serious in multi-HOI scenes. The second challenge is ambiguous localization. A generic query such as a person riding a motorcycle may refer to multiple people, causing the grounding model to locate the wrong person or object. To better tackle complex scenes, we incorporate two key components, a context-aware multi-round reasoning mechanism, which iteratively refines interaction recognition results through progressive querying, and a multifaceted interaction localization mechanism, designed to reduce ambiguity in interaction localization. Together, these modules constitute the complete AgentHOI system. Our context-aware multi-round reasoning mechanism turns interaction recognition into a course-to-complete search and contains three stages, as illustrated in the upper part of the figure. In the first stage, initial HOI identification, the MLM produces the most plausible action-object pairs in the image. This gives us an initial interaction set, but it may be incomplete. In the second stage, HOI remining, we use the interactions already discovered as contextual anchors and ask the MLM to search for additional interactions. In the example shown here, the first response identifies carrying a bottle, while remining helps uncover another interaction involving the apple. In the third stage, assignment, we provide object-specific action priors and ask the model to reconsider all plausible actions for each human-object pair. This helps recover concurrent or fine-grained actions, such as both carrying and holding the same object. To generate distinctive descriptions for localization, we ask the MLM to generate instance-specific descriptions that combine three types of information: semantic cues, such as the action and object category; spatial cues, such as left, right, or relative position; and appearance cues, such as clothing, color, or accessories. For example, as illustrated in figure below, instead of only saying a person holding a bottle, the model can describe the person on the left wearing a black shirt and a hat, and the bottle with a red label. We evaluate AgentHOI on two benchmarks, HICO-DET and SWIG-HOI. On HICO-DET, we consider four zero-shot settings: unseen verbs, unseen objects, rare first and non-rare first unseen compositions. To evaluate robustness beyond the original test distribution, we also construct style-transferred images and degraded images, blur, noise, and compression artifacts. These settings simulate the appearance shifts and image quality variations that frequently occur in real-world applications. We evaluate performance using mean average precision. A prediction is correct only when it identifies the interaction and localizes both the human and object. This table compares AgentHOI with existing methods under the original and shifted test distributions. On the original images, AgentHOI achieves the best performance for unseen verbs and rare first unseen composition settings. The advantage becomes more evident under distribution shifts. We next evaluate generalization on SWIG-HOI, which has a much larger and more diverse interaction vocabulary. Without any dataset-specific HOI training, AgentHOI's unseen class performance surpasses the fully supervised CMDSE result and approaches SGCNet. Ablation study shows that each module, including context-aware multi-round reasoning abbreviated as CMR, Multifaceted Interaction Localization, abbreviated as MIL, shows performance gains. Combining the proposed modules achieves the best result. Finally, we examine the qualitative behavior of AgentHOI. The examples on the left shows that AgentHOI can recover plausible interactions that are missing from the annotations. For example, it recognizes the person walking the dog, even though this interaction is not included in the ground truth. The examples on the right demonstrates that AgentHOI can produce open-ended interactions. In the horse example, the annotation contains only ride horse, while our method also identifies related actions such as straddling the horse, holding the lasso, and swinging the lasso. Thank you for your attention. The paper, code, and project page are available through the QR codes.